Hello, today we need to solve the irrational equation of this kind. The specific feature of this equation is that it contains square root and modulus. The square root is common for irrational equations. In opposite, the modulus is not. Its role will be considered in detail at the end of this video, where we compare solution of this equation with one of the same type, but without the modulus. As usual, as the first step, we will find domain of an equation. We have here square root. It means that a radicand, 5 minus x, must be non-negative. We rewrite this inequality in this form, and we take into account that the right-hand side exists at any x and doesn't provide additional restrictions for domain. So our domain is defined by this inequality, and geometrically we can represent it as follows. Now we go to the next step, calculations. First, what we need to do is to take square of both sides of our equation. Before we proceed, I would like to suggest you the following quiz. We have 4 options for square of modulus. Which option is correct? You have 5 seconds to find the answer. Okay, couple bonus seconds. What is the answer? Please report. John said 1, option 1. Jen reports option 2. And online student report option 4. So 3 different answers, which is correct. Correct is option 2, and we will use it for calculations. How the formula 2 was found, asks online student. Now let's consider definition of modulus. It is here. We see that if we find square of the, it will be modulus square, then the square of the right hand side will be square of either a or negative a, and in both cases it gives us a squared. And this is a proof of this formula. Now we continue calculations. First we square both sides. Here we have this equation. We expand the right hand side, simplify, and we have quadratic equation for x. We apply well-known equation of algebra for the roots of quadratic equation. Calculations are straightforward. Let's do them. And we have two roots, x1 equal 1, when here is plus, and x2 equal negative 4, when here we take minus. We remove what we don't need. And now we need to verify these roots. First we mentioned that square root is always non-negative. Modulus is also non-negative. So both sides are non-negative. It means that when we square both sides, we will not get extraneous roots. For this reason, the only thing we need to do is to check whether both roots are in the domain of equation. Our domain is here. First root is here. Second is here. Both are in domain. It means that these two roots are correct. John has a question. Please, do we need to substitute the roots to original equation? No, because in this specific case, as it was discussed above, we don't need to do this. We just check if these roots belong to domain of equation. But you may want to do this to double check if your solution is correct. Jen has a question. If in original equation modulus x plus 1 is replaced with x plus 1, quadratic equation remains the same. What about the roots of new equation? Good question, Jen. Let's consider it in more detail. So we have now this equation without modulus, and if we square both sides, we will get exactly the same quadratic equation as previous. And of course, we will have the same roots for this equation. But the domain of the new equation is different from the domain which we had before. Let's consider this. Now we have, in the right-hand side, we have just x plus 1, and this x plus 1 can be positive and negative. It cannot be negative because on the left-hand side we have non-negative value 5 minus x square root. So the right-hand side must be also non-negative, or x should be greater or equal negative 1. This condition is additional restriction to domain of this equation. Our previous domain shown here, new domain, is this one, from negative 1 to 5. It means that if we put our roots on the number axis, one of them will be outside of the new domain. And this is incorrect root. So the answer is x1 equal 1 and no other roots. Did I answer your question, Jen? Yes. Good. So we can write the final answer for our problem, and this problem is solved. If you have the other solution of our problem, please share it with us using comments, and we will discuss them later. And the last thing, I would like to ask you to help Dr. B in his work on future videos. You can help him with your likes or even dislikes, subscription, and positive or negative comments. Thank you for your help.